These pieces came in. They are impeller locks. I used to work at a pump component outfit many years ago for about 6 months and learned all kinds of things about impellers, and have used lots of impellers over the years. So basically, I recognized this. And the way that this lock works, this goes into a groove in a shaft. So you get both halves, make a groove in a shaft. In the impeller, this bolts onto the end of the impeller. And generally, to make it more secure, there will be a counterbore in the impeller. So this sets down tight in the impeller, covering up the groove that was cut in the shaft. And there'll be some other way to make the shaft rotate. This is just to position it lengthwise on the shaft. And then these bolt in, that locks, and it goes in the counterbore. In fact, specifically in this one, they even told me that the impeller was keyed onto it. The one thing that they did remind me of, and it was a good thing they reminded me of it as opposed to just tossing this at me, was that it needed to be stainless steel, which a lot of pumps are not stainless steel because they can just rust away and be fine. But this one works submerged in cyanide solution its whole life, which eats up regular steel. So yes, needed to be stainless. Since we didn't have handy the right size of stainless, we went ahead and ordered 303, which is supposed to be easier to machine. This is their first time that we specifically ordered 303 for a project like this, and yes, much easier to machine. We're spending a couple bucks extra on. I wanted to get tubing, but the only tubing that I could get was real close to the right size, so we might not have been able to machine it to be correct. Now, not knowing, not having the actual pieces as a sample, just having the lock, had to decide on the ID, on the OD. But as it turned out, they were really, really close to fractional sizes. Now, when you're measuring this, you can't measure straight across this way, but you can measure across sideways between your two pieces. And that will give you very little difference with your kerf being gone, and then you can measure your inside across the two the same way. You can also take and guess and play with shim stock, but I've done this enough. I was getting measurements within a couple thousandths of standard sizes, which I forget. The outside was 3 3/4. The inside, you worked on these, Bert, was this 1 3/4 or 2 inch? I think it's 1 3/4 on the inside. Yeah, 1 3/4. So they're on the shaft groove, they would have had a 1 3/4 or deeper. It would have been dimensioned out either to the depth of 1 3/4 or a smaller diameter, or it would have told them from the actual diameter of the shaft, which you can see on here. Now, if I had to make the shaft, it'd be tough because I wouldn't quite trust these lines of where the shaft was for the diameter. Is it an inch? Is it a millimeter? That would be a little harder to guess at and feel like I was doing right. One thing also that, of course, is going to be important on this is the thickness. Now, if all I had was the place where the impeller had been here and it was wearing a little bit, that had worn down a little thin, then I'd have a bad sample. But if you come back here, you can find some nice smooth material that hadn't been messed with, and it was right at 375 everywhere I measured it. So 3/8 of an inch is the size. Again, we went with a minus tolerance because if it fits in the groove, and some of them were at 374. If it has 1/1000ths of movement, we're not going to die. But if it is 376 and they have to pound it in with a hammer, they're going to say we're stupid. We don't like them to say we're stupid, even though sometimes we might, we don't want them to say it at least. So that was that. We made this as it was out of shaft. So since we were making it out of shaft instead of tubing, if it was out of tubing, instead of drilling it, we would have, and actually I think we came out better making it out of shaft the way we did it. Because if I made it out of tubing, we would have came in, and a lot of times your material selection chooses how you do something, and sometimes it's not always the best. So if we had made this out of tubing, my thought, which is the normal way you'd go on tubing, is turn the outside, bore the inside. So the two match, 0 run out, okay? And that's the way you'd normally do it. If you're setting this up on a CNC, you would have the machine turn the outside, bore the inside, and then part the piece off. Well, when you part it off, of course, your parting tool's not going to give you absolute thickness, so we're going to have to come back, separate operation. It's going to wander a little bit, no matter what. That's just what a parting tool does. So to get the thickness as accurate as we want, we would have had to come back with a second machine and deal with the thickness to make it more accurate. But it's the same thing, which here we were doing it with manual machines. We were not going to part them off here with our manual machines. It just really was not the thing to do at all. And also you've got the holes to drill. Again, if we were doing it on our CNC over there, we would have drilled the holes with the live tooling. As it was, what we did was we did these in multi-steps. We started out, we turned the whole stock, so it's two sides. And then our saw cuts nice and straight, so we cut off a lot of little wafers. Then we set up soft jaws on our lathe so that the soft jaws would allow us to drill the center hole, bore the center hole, gave us lack of run out without a lot of dialing things in. We just used them on the milling machine with a dividing head as far as for drilling these holes. And we used a short drill. So using a short drill, you don't have to center drill. You can just plain drill right in and it will locate the holes where you need them. So that's an advantage in time savings there. That's pretty much the thought process on it. Oh, and splitting it. Splitting it was another interesting thing. This one here, sides all wonky. They just, obviously, these were probably made by a CNC machine. But for whatever reason, when it came to splitting them, they just went to a manual bandsaw and just cut them in two afterwards. And but you see that in some shops. Not every fancy machine in the world, even in the fanciest of manufacturing plants, has everything. So they just held these by hand in a bandsaw like you'd usually have in a pattern maker's shop, which we have one like that too in our back room, but we don't use it for things like this. Things like this, we use our big saw, and we made a fixture that this actually laid down fixture that this actually fit in, bolted it with 2 bolts. Point being, these ones here are matched. They have to go together. Every one of them has to go together. The ones that we made, while we still sold them to them in matched sets, these are the same. You could mix the first one with the 20th one of these that we made and it wouldn't matter. These ones are all the same, so didn't need to be. They wanted them in matched pairs. We tied them together so they're nice and pretty, but I kind of like them just being the same anyway instead of a left and a right that has to be the exact same pair or they don't fit. And they were mentioning that too, where they're using these, that they said that, yeah, they found out early on, they really meant you had to not mix them up. Because they had some of them where, no, it would not go in if you got them wrong, because they were not even, this one's fairly centered, but you know, some of them way off, so that you get 2 of them and the bolt holes aren't going to fit. They're just wrong. Now, why did we get this job instead of from the manufacturer? Is it because the manufacturer wants $600 a piece for a pair of these? I have no idea what they want. It's because they no longer make these. They have a new design for the impeller that goes on a new model of shaft with a nut on it that's threaded and holds the impeller on. So, but they already had 45 of these impellers that they've got in stock, along with shafts that fit them. So that's why they wanted us to make the part that keeps them going through the end of life for this particular design, since I don't know why they would drop the locks. Just I also don't know why you would buy 45 impellers without having at least some spare locks. Anyway, we got the job, we did it, saved the day, like we always do.